Okay, so we're going to talk about another transformation. This one is rotation or turning. Clearly I wrote that incorrectly. So rotation or turn. So here's our original shape, triangle IJK. So let's look at the coordinates of those points. I is at -1, 2. And J is at -5, 3. And K is -4, 0. So when we do rotations, there's two pieces of information you have to give. Actually, three pieces of information. You have to say what direction. So in this case, clockwise or counterclockwise. So clockwise is this way, counterclockwise this way. You have to say how many degrees. It could be any number of degrees. We're going to do increments of 90 degrees since we're doing it without using a protractor. So it could be 90, 180, 270, or 360 would be all the way around. And you have to say where the point of rotation is, the center of rotation. So for ours, we're going to be rotating around the origin, or around 0, 0. So this is a rigid transformation. That means that the pre-image, or the shape you start with, the original shape, will be congruent with any image, meaning that if I rotate this shape to this position or this position, this shape and this shape are congruent. So the pre-image and the image, or the pre-image and this image, are congruent, meaning same side length. JK is the same length as J prime, K prime. For example, angle I is congruent to angle I prime, because they're corresponding angles or sides. So let's look at these moves and see some tricks about them. So for example, this first one we'll do, let's do a 90-degree rotation. So we're going to rotate IJK 90 degrees clockwise. So that first move would be rotate 90 degrees clockwise around, or sometimes people say about, the origin. So that's this move, to rotate this shape here. Now this is already drawn for you, but if you had to do it yourself, I want you to see something, that a 90-degree turn. So if I'm rotating around the origin, it's basically moving the shape one quadrant. So this is 90, 180, 270, 360. So if you want to visualize, if it's hard for you to visualize, you can just like take this little graph that I made here. I drew the original shape, and if I turn 90 degrees, that's 1/4 turn here. And now you can see that these shapes are in the position. I'll do that again. So a 90-degree clockwise turn, I just turn the whole graph 90 degrees, and these two are matching. So this is that new position. Excuse me. So that's a good technique if you're having trouble visualizing. 90 degrees counterclockwise, right? You can see they match. We'll do that one again in just a sec. Let me just make a little correction on my drawing here. Make sure it's correct. Okay, great. So let's look at patterns with how this changes. So when I do this 90 degrees again, right, starts out here, goes like that. These guys look the same. Let's look at what these new coordinates are. So I prime moves to 2, 1. This is I prime. And J prime is at 3, 5. and k prime is at 0, 4. So if we look at if there's some kind of pattern in the way these change, now this is for a 90-degree clockwise turn, we can see that the y coordinate became the x coordinate. So whatever was your y coordinate is your new x coordinate. So this y coordinate is a 2, my new x is a 2, and that's because that, right, the x-axis, when you turn that, is becoming the y-axis, right? So it's like this was the x-axis, but if I turn, now it's whatever was on the x-axis is on the y-axis. And we had -1 for my x, and that goes to the y position except the sign changes. So that would be, this means a change in the sign of your old x value. So let's take that all the way down. So move that up so you can see that. So again, this, my old y value is becoming my x value, and my old x value is becoming my y value, but the sign is changing. So my old y value is becoming my x value, right? Y was 0 in the pre-image, and now 0 is your x coordinate. And then my y value is what used to be my x, but switched the sign. And that's for 90 degrees clockwise. So that's rotating 90 degrees clockwise, right? All these points rotate 90 degrees clockwise. So obviously the orientation of the shape changes, like I is pointing to the right, now I prime is pointing down, but the orientation of the vertices stays the same, right? I can read this ijk, or sorry, ijk, I read it right now counterclockwise, ijk, I'm reading it counterclockwise. So the orientation of the vertices, meaning the order you're reading the letters as it is positioned, does not change. Let's do 90 degrees counterclockwise. So that's from this position to this position. And again, if we look at the original shape, 90 degrees counterclockwise moves it 1 quadrant, 1/4 of the graph for each 90 degrees. So we see that these guys match. So again, if you're having trouble visualizing how the position of the shape will be when you're done, just draw a graph and then turn it on your own there. So we can see these guys match. So again, let's look at the coordinates. So I prime now is -2, 1. And j prime is -3, -5. And k prime is 0, -4. And this one would be a rotation, or to rotate 90 degrees counterclockwise. So that's this turn. So now we're showing this turn here. So this was clockwise, and this is counterclockwise. And again, you have to say the point of rotation that you're going around, which in this case, around the origin, right? We're turning around this point, right? So it's like there's this imaginary line, and there's your 90 degrees. So there's this imaginary line to say I, and then to I prime, there's your 90 degrees. So let's see what the rule would be for a 90 degrees counterclockwise move. So my old coordinate of I was -1, 2. So in this case, the 2, which was my y coordinate, becomes my x, but the sign switched, so we would call that -y. Oops, this is supposed to be -1. Whew, close call. And then my old x coordinate, -1, becomes my y coordinate. So I use the old y for the x, but switch the sign, and then I use the x coordinate for my y coordinate in the image, but but don't change the sign here. So -1 just jumps over to the y. So let's follow that all the way down. Oops. So I had -5 for x here for j, and then on j prime, the -5 is my new y coordinate. So you can see in the position of the y coordinate we put in x, this meaning the old x coordinate. So this is the formula for the rotation, or the expression that represents the rotation. Use your old x coordinate for your new y coordinate. So my old x coordinate was -5, I'll put it in place of y over here. And then I put my y coordinate in place of my x coordinate, but flip the sign. 3 becomes -3. Same thing here, -4 becomes -4, but in the y place. And 0, flip the sign, but you can't flip the sign of 0, it doesn't have a sign, so it just stays 0. So for rotation 90 degrees clockwise, there's the formula. And remember, it's 90 degrees is one quadrant move, so this guy moves one quadrant clockwise or one quadrant counterclockwise. So one more possible rotation, if we're going in 90-degree increments, would be a 180-degree turn. So let's go down and look at this 180-degree turn. And remember, when you're watching the video, feel free to pause it if you want to look at something longer than I'm looking at it, or go back and look at it again. Sorry, I've made a couple little mistakes, but I've corrected them on this video, so sorry about that. So anyway, so here we're going to do a 180-degree rotation. So we're going to take triangle JKL, right? We're going to rotate this around 180 degrees. And we don't need to say clockwise or counterclockwise, because either way we would end up with the same position. But again, it's really useful. So kind of take a little graph that you can turn, and then turn it 1, 2 moves. 90, 90 would be 180. So you can see that's going to be the new position. And that can be very helpful in visualizing, which direction each of these vertices is going to end up pointing. So I'll do that again. So if you have the original or the pre-image, 90, 180, there it is in the new position there. So my original coordinates, JKL, so J is -4, -4. K is -3, -2. And L is 0, -3. So the move, I guess I'll leave that there. The move we're doing is rotate 180 degrees around the origin. And we don't have to say clockwise or counterclockwise, because it doesn't make any difference. There's no way to really tell. And then the algebra expression for this, let's check out. So let's see where J prime ended up, K prime and L prime. So my J prime is now at 4, 4. And my K prime is at 3, 2. And my L prime is at 0, 3. So -4, -4 became 4, 4. -3, -2 became 3, 2. And 0, -3 became 0, 3. So we just switched all the signs. So just flip the sign of x and flip the sign of y. So if I plug -4, I would get -4 is 4. If I plug in -4 here, I get -4 is 4. Same thing here, -3 is 3. -2 is 2. So for a 180-degree rotation, you just change the sign of both coordinates. And no, you don't need to reverse them. X stays X, just flip the sign, Which makes sense because, right, we're down here in the coordinate where the x's are negative and positive, and that rotates it up either way to the positive, the first quadrant. So from quadrant 3 to quadrant 1.